temperature equal to 75 degrees Celsius minus 25 degrees Celsius equal to 50 degrees Celsius. Mass equal to 450 grams. Specific heat capacity equal to 0.3852 joules per gram degree Celsius. Change in thermal energy equal to mass times specific heat capacity times the change in temperature equal to 450 grams times 0.385 joules per gram degree Celsius times 50 degrees Celsius equal to 8,662.5 joules. Number 2. A pot is filled with 9 kilograms of water at 10 degrees Celsius. Calculate how much heat energy will be needed to raise the temperature to 60 degrees Celsius. Specific heat capacity of water equal to 4,200 joule per kilograms degree Celsius. Solution. The change in temperature equal to 60 degrees Celsius minus 10 degrees Celsius equal to 50 degrees Celsius. Mass equal to 9 kilograms. Specific heat capacity equal to 4,200 joule per kilogram degree Celsius. Change in thermal energy equal to M times C times delta to 9 kilogram times 4,200 joule per kilogram degree Celsius times 50 degrees Celsius equal to 1,890 kilojoule.
Okay, so question 3. The first question is 21,000 joules of energy is transferred to 5 kilograms of water. If the specific heat capacity of the water is 4,200 joule per kilogram degree Celsius, then we should calculate the changes in the temperature. So first, we're going to put up all the mass, or M, which is 5 kilograms, and then we're going to put up the specific heat capacity, which is C, which is 4,200 joule per kilogram degree Celsius, according to the question. And then we're going to put up the change in thermal energy, which is delta E, which is 21,000 joules, according to the question. All of that, we're going to sum it up into one simple formula, which is the formula of the change in temperature, or delta theta. So it will become delta E divided by the specific heat capacity times mass. So it becomes 21,000 joules divided by 4,200 joule per kilogram degree Celsius times 5 kilograms. So the final result is 21,000 divided by 21,000. So it will become 1 degree Celsius. So the answer is 1 degree Celsius. Next question. Okay, question 4. 2,500 grams brass kettle is heated with 10,450 joules of energy, which makes its temperature raise up from 25 degrees Celsius into 80 degrees Celsius. So we should calculate the heat capacity of the kettle. So first, we're going to put up the solution, which is the change in the temperature, or delta theta, which is 80 degrees Celsius subtracted by 25 degrees Celsius. So it will become 55 degrees Celsius. And then we're going to put up the mass, or M, which is 2,400 grams. And then we convert it from gram into kilograms. So 2,500 grams will become 2.5 kilograms, according to the question. And then the changes in the thermal energy, or delta E, which is 10,450 joules. And then we're going to put up and sum it up in one simple formula, which is the formula for specific heat capacity, or C, which is delta E divided by the mass times the changes in the temperature, which is 10,450 joules divided by 2.5 kilograms times 55 degrees Celsius. So the final result is 10,450 divided by 137.5, and then the answer is 76 joules per kilogram degree Celsius. So the answer for this question is 76 joules per kilogram degree Celsius. Okay, so thank you everyone, especially to Mr. Marcel for listening and watching for our presentation from our group. We want to say thank you a lot for the honor and great pleasure for Mr. Marcel and all of the boys, all of the girls that have been listening for our presentation. It has been a great honor, and we believe that this presentation will always gonna be useful in the next couple of years. So thank you from our group.
Okay, thank you so much.